MS Ramaiah University of Applied Sciences.
Hi students, let us discuss determination of coefficient of permeability. The aim of the experiment is to determine the coefficient of permeability of coarse-grained and fine-grained soils. Permeability is a measure of the ease in which water can flow through a soil volume. Permeability controls the strength and deformation behavior of soils. Coefficient of permeability refers to the rate of flow under laminar flow conditions through an area of unit cross-section under a unit hydraulic gradient and at a standard temperature of 27 degrees Celsius. This test is recommended for soils with coefficient of permeability in the range of 10⁻³ to 10⁻⁷ cm per second and maximum particle size of 9.5 mm. The most common laboratory method of finding out permeability are constant head method for coarse-grained soils, variable head method for fine-grained soils. Permeability is very essential in engineering problems involving flow of water through soils such as dewatering and drainage of excavations, backfills and subgrades, assessing seepage through the body of earth dams, computing losses from canals, determining yield of water-bearing strata, design of landfill liner. Experimental setup: set of glass tank pipes, constant head tank, metallic mold, drainage base plate, porous stone, IS sieves, mixing pan, graduated cylinder, stopwatch, source of de-aired water and thermometer. Experimental procedure: constant head permeability test, preparation of the soil specimen. Take 2.5 kg sample from a thoroughly mixed air-dried or oven-dried material. Determine the initial moisture content of the soil sample. Place the sample in an airtight container. Add required quantity of water to get the desired moisture content. Mix the soil thoroughly. Weigh the permeometer mold to the nearest gram. Grease lightly the inside of the mold and clamp it between the compaction base plate and the extension collar. Assembly should be placed in a solid base and filled with sample and compacted. Once the compaction is over, remove the collar and excess soil should be trimmed level with the top of the mold. Obtain the weight of the mold with sample. Place the mold with sample in the permeometer with drainage base and cap having discs that are properly saturated. Connect the specimen through the inlet to the constant head water reservoir. Open the outlet and when a steady state of flow is established, collect the quantity of flow for a convenient time interval and measure it. Measure the heights h1 and h2 to determine the head loss, h equal to h1 minus h2. Collection of the quantity of flow for the same time interval shall be repeated thrice. Falling head permeability test. Soils of low permeability shall be subjected to a gradually increasing vacuum with bottom outlet closed so as to remove to form the soil voids. Saturate the specimen with de-aired water from the bottom upwards under full vacuum. Close the top and bottom outlets once the sample is saturated. Connect the sample to the standpipe through the inlet. Allow some water to flow until steady flow is obtained. Note the time interval required for the water level to fall from a known initial head H1 to a known final head H2. Record the area A of the standpipe. During the test, initial time Ti and initial head H1, final time Tf and final head H2 should be recorded. Weigh the wet sample and record it. Data collection and tabulation for constant head permeability test and falling head permeability test are shown in the table. Calculations and computations. For constant head permeability test, coefficient of permeability K is calculated using the formula shown. For falling head permeability test, coefficient of permeability K is calculated using the formula shown. The results of coefficient of permeability K for constant head permeability test and falling head permeability test are presented.
Hello students, today we are going to study about permeability test. This test is as per IS 2720 part 17. The test is required to find out the coefficient of permeability for both coarse grained pavement material as well as the fine grained pavement material. This experiment has two parts in it. One is what we call as the constant head permeability test, which is applicable on coarse grained material, and the other one is the falling head permeability test, which is required to be conducted on fine grained material. Before we start with the experimental process, we need to have an understanding about the experimental setups that are involved in this particular process. This is the mixing tray. Mixing tray to mix the soil with the required quantity of moisture, and the trowels that are required to mix the soil, the base plate which is required to hold the permeability mold on place. This base plate has corrugations in it, or vents in it, or channels in it, which helps in the exit of water through the exit tap what we have. 1000 cc measuring cylinder, 100 cc measuring cylinder, 1000 cc measuring cylinder, which is required during the casting process of the specimen, and the 100 cc measuring cylinder, which is required to measure the quantity of water or fluid passing through the specimen during the test. The filter papers, these are the filter papers that are required to be placed on the top and bottom of the specimen during the test process. Stopwatch, this is the stopwatch required to measure the time taken by the fluid to pass through the specimen during the test process. The bottom porous plate, top porous plate, these are the two porous plates that are required to be placed at the bottom and at the top of the specimen to be subjected to this particular test. The base plate required for compaction, the steel plate of 100 mm dia, which is required to be placed in place of the porous plate during the compaction process. The permeability mold of approximate inner to inner diameter 10 centimeter and the height of 12.7 centimeter, the collar and the lid, which is having a gasket in it, which sees to it that the mold is subjected to a watertight situation during the test process, and the ring which must be placed above the base plate, the bottom ring that holds the permeability mold in position. The nuts and bolts, these are the nuts and bolts that are required to tighten the mold to the base plate. Oil dispenser, the oil dispenser that is required to smear the oil on the inner surface of the mold during the casting process. Measuring scale, required to measure the dimensions of the specimen before test. Spatula, required to trim the specimen before subjecting it to the test. Spanner, 16/17 spanner, required to tighten the nuts and bolts to fix the specimen in position. Hammer, which might be required during the casting process of the specimen. Brush for the cleaning process. Rubber tube that is required to be connected with the water source to the specimen during the testing process. weighing balance, the weighing balance with a maximum capacity of 10 kilos and the accuracy of 1 gram shall be taken during the test. The tray consisting the soil. This is the soil which is oven dried, which is obtained after sieving through this sieve set consisting of the pan, the IS 4.75 sieve and the lid at the top. This sieving process can be done manually or by making use of the mechanical sieve shaker. We have taken approximately 3 kilos of oven dried soil for the experiment. Once we are clear about the various experimental setups that are required to conduct this experiment, it is now time to prepare the mold for the casting process. To begin with, we need to first place the steel plate at the bottom for the compaction process. Now, place the permeability mold on the base plate for the compaction process. Place the metal ring to hold the mold in position with the base plate. Tighten the nuts and bolts properly in place such that the mold is held firmly with the base plate. Once the mold is properly tightened and fixed with the base plate, it is now time to place the collar in position over this mold. See to it that you be careful in placing the collar on the mold by taking care of the groove that is being provided. Place the washers and then the nuts and tighten them evenly. Once the tightening process is done, we are now ready with the mold for compaction process and sample preparation. Before we start with the compaction process, we need to ensure that the inner surface of the mold is smeared with oil properly by making use of the waste. Take a waste cloth and smear evenly the oil throughout the mold from inside. This process of preparation of the mold for compaction will remain the same for both constant head permeability test as well as the variable head permeability test. We can also conduct these tests on undisturbed specimen also, from the specimen that has been extracted from the site and tested directly by keeping it in the mold. Here we are going to conduct this permeability test on disturbed specimens which can be casted like the way it is going to be shown now. Once the mold is ready for compaction, it is now time to prepare the soil by mixing the soil with a known quantity of water, which might be either the optimum moisture content or the moisture that is available at the site. Here we are assuming that we are going to prepare a specimen at the optimum moisture content to achieve the required density during compaction. So we are going to take the predetermined water of around 300 ml and sprinkle it over the soil like the way it is shown. Mix the soil now by making use of the trowel evenly such that there are no lumps left in the mix. This being a coarse grained soil, a granular soil, we are going to make use of this material to conduct the constant head permeability test. The soil is now ready after being mixed with the optimum moisture, and now we can compact the soil in the permeability mold. For the compaction process, we can make use of the modified compaction method by making use of the modified rammer or the heavy rammer, or we can make use of the standard compaction rammer, that is the lightweight rammer. Once we are clear with which rammer to use for the compaction process, we can now start with the compaction process. To begin with the compaction process, I have assumed to use the light compaction process, and hence I am using a rammer weighing 2.6 kilos. The sample, which is now prepared by mixing with the water, shall be divided in 3 equal parts. Now place the filter paper at the bottom. And once it is placed, start transferring the soil into the mold in 3 different layers. The first layer is now being placed inside the mold. Make sure that the material is loosely placed evenly and having a even surface at the top. Once the first layer is placed, it is now time to compact the specimen by giving 25 number of blows evenly distributed throughout the surface. After giving 25 number of blows, it is now time to remove the rammer out and scarify the surface by making use of the spatula. This scarification is required for receiving the next layer, that is the second layer for compaction. The same process of compaction by the transfer of next layer material has to be repeated for the third layer as well. Now we have compacted the third layer, and it is time to remove the collar out and trim the specimen for the test process. Make sure you clean the excess soil out and dispose it on the tray. Loosen the nuts like the way it is being shown, and gradually turn the collar and extract it out. Make sure the specimen is not disturbed. Trim the excess material by making use of spatula. Once the surface of the mold is trimmed, it is now time to clean the excess soil and start loosening the bolts that are used to firmly place the mold with the base plate. Once the nuts and bolts are removed, it is now time to lift the ring which holds the mold firmly with the base. Lift the mold out carefully without disturbing the specimen. Keep the mold that has been compacted aside. Remove the steel plate out and replace the position with the porous plate. This space will now be accommodated by the porous plate for the test process. Place the porous plate like the way it has been shown on the base plate. Once the porous plate is placed, then transfer the casted mold back onto the base plate. Make sure the porous plate is saturated, and then transfer the ring back onto the base plate, which is required to hold the mold on position. Tighten all the nuts and bolts. Once all the nuts and bolts are tightened, which holds the mold firmly with the base, place the filter paper on top of the specimen, and then the porous plate again on the filter paper. Later, place the lid of the permeability mold like the way it is shown. This lid ensures a watertight situation for the test. Place the nuts and tighten them evenly. Once all the nuts are tightened, we are now done with the preparation of the specimen to be tested for permeability or the determination of coefficient of permeability. We are now ready with the specimen here to be tested with the constant head permeability test setup, which involves a reservoir which holds the water, and the level of water will be measured with the help of this tube which has the water meniscus shown, which correlates with the scale that has been placed aside. Before we start with the test, we need to measure the total head with respect to the exit pipe and its center. So the distance between the center of this exit pipe and the water level in the reservoir need to be measured. We can make use of the steel scale to have an excessive measurement above the limit of the scale which is placed with the reservoir. For that, place a metal scale in level with the reservoir. Take one more steel scale and measure the total height with respect to the center of this exit tube. Once you have measured it and once you have noted down in your observation column, it is now required for you to connect the rubber tube with the exit of this reservoir to the inlet of this specimen. The total height that we measured from the water level till the center of this exit pipe is required in the calculation of coefficient of permeability. Once we have given the connections to the rubber tube with the exit of the reservoir and to the inlet of the specimen, it is now required for us to see to it that the specimen in this mold is completely saturated. When I say being saturated, it means that whatever water that flows through the reservoir, the quantity must be the same coming out from the exit. So, to start with, switch on the tap from the exit of the reservoir, and there is a nut here which is required to be opened to exit the air out, such that there is a smooth flow of water through the specimen inside the mold. Allow the water to pass through the tube inside the specimen and allow it to get saturated unless you get a constant flow from the exit. Once it is ensured that we have a constant flow, it means that the soil inside the mold which we have casted is completely saturated. So it can be seen that the exit of the water and its flow is constant, and hence it shows an indication, or it gives an indication that we can start taking readings and start with the experimental process. So to begin with, before you start taking the readings, it is required for you to measure the head of the water with respect to the reservoir which holds the water. So measure the head till the center of this exit pipe and start will be experimental process. So here, once we have ensured all the experimental setup to be in place, we need to take this 100 cc or 100 ml measuring cylinder, and the time required for the water to flow through this exit pipe and get collected in this measuring cylinder is noted by making use of this stopwatch. So make sure you open the exit tap, and the moment you open this exit tap, you need to make sure that you switch on the stopwatch and measure the time required to fill 100 ml of water in this measuring cylinder. So we shall start with the experiment. I would have measured the head by now, and then I open the exit tap, and the moment he opens the exit tap, I switch on the stopwatch. So the time required to fill 100 ml will be measured in seconds by making use of this stopwatch, and this time is what is being noted in the tabulation column that is being supplied to you. Taking this reading number of times will give you a constant reading in terms of time taken by the water to flow through the specimen, and that gets collected in the measuring cylinder, and making use of this you can do the calculations and find out the coefficient of permeability by this experiment, that is constant head permeability test setup, to find out the coefficient of permeability for coarse grained soils. We shall now begin with the second set of experiment which is required to find out the coefficient of permeability for fine grained soils. We have prepared the specimen like the way it was shown to you at the beginning of this experiment. The specimen is being casted, and it is ensured that the specimen inside the mold is completely saturated because we have a constant flow of water through it. Once it is ensured that the specimen is completely saturated, we need to connect the specimen through the inlet by connecting this rubber pipe from the outlet of this draft tube. So we have three sets of draft tubes here. The draft tube will be followed by the placement of the measuring scale. Fill the draft tube with the help of water by making use of the measuring cylinder. Measure the internal diameter of this draft tube and start with the experiment. Before we begin with the experiment, measure the initial head with the help of the scale. the meniscus need to be coincided with the scale. Note it down as the initial head. Once the initial head is being measured and once you have tabulated it in the tabulation column that is being supplied to you, you start the exit pipe of the specimen. So the time required for the head to fall from H1 to some predetermined H2 will be measured by making use of this stopwatch. The initial head was noted down, and once we open the exit pipe, the final head will be known to us. So the time required for the fluid to flow through the specimen from this H1 to a predetermined H2 will be found out with the help of this stopwatch. Make a note of the time 2 to 3 times or even 4 to 5 times as per your convenience, and take an average of the time taken for the water to reach from H1 to H2 and use it for the calculation of coefficient of permeability for the fine grained soil that is being casted in the mould. So this would be the end of the permeability test, both by the constant head permeability test setup as well as the variable head permeability test setup. Thank you.
At MSR UAS, we spark your imagination unlike any other.